You open your electric bill, glance at the number, and do a double take. Maybe it's a little higher than last month. Maybe it's a lot higher. At first, you blame the usual suspects. The air conditioner, the heater, the kids leaving lights on, that old refrigerator in the garage. But what if part of the reason isn't even in your house? What if some of that pressure on your electric bill is coming from giant buildings full of computers located miles away, running around the clock? The simple answer is yes. You know what? Let's dive into it, here, right now. One reason electricity prices are rising is the growing demand from AI and the massive data centers that power it. And once you see how much electricity these facilities use, the connection starts to make sense. Think about how often you interact with the internet during a normal day. You send a text, watch a video, ask an AI chatbot a question, store photos in the cloud, stream a movie at night. It feels like all of this happens in some invisible digital world. But behind every click, every search, and every AI response is a physical machine somewhere doing the work. Those machines live inside data centers. A data center is basically a giant warehouse packed with computer servers. Imagine row after row of metal racks filled with powerful computers, thousands of them. Sometimes hundreds of thousands. They run day and night. They never sleep. And they all need electricity, lots of it. For years, data centers were already important because they powered websites, video streaming, cloud storage, online shopping, and social media. Then AI arrived, and AI changed the equation. When you search the web, a computer may need to find information and send it back. When you ask an AI a question, the system often performs far more calculations behind the scenes. AI models process enormous amounts of data and require powerful chips that consume significant amounts of electricity. Now, imagine millions of people doing that every day. Then imagine businesses doing it, schools doing it, hospitals doing it, developers building AI tools, companies training even larger AI systems. Suddenly, the demand for computing power starts growing much faster than before. And that means more demand for electricity. To understand why this matters, picture your local power grid as a giant highway. Every home, business, school, factory, and office is trying to use that highway. For a long time, traffic increased gradually. Utilities could usually predict demand years in advance. Then, huge AI-focused data centers started appearing. Some of these facilities require as much electricity as a small city. Others are even larger. When several major data centers are built in the same region, utilities suddenly face a challenge. They need more power generation, more transmission lines, more infrastructure, more capacity. Building all of that takes time and money, and eventually, those costs have to be paid somehow. Now, this doesn't mean your electric company sends you a bill labeled AI fee. The connection is more indirect. Electricity prices depend on many factors: fuel costs, weather, power plant construction, grid upgrades, government regulations, local demand, and increasingly in some areas the demand created by large data centers. Think of it this way. Imagine a small town where everyone drives normal family cars. Traffic is manageable, road maintenance is predictable. Then several giant distribution warehouses open nearby, sending thousands of heavy trucks onto the roads every day. The town suddenly needs wider roads, new intersections, and more maintenance. The transportation system becomes more expensive to operate. The electric grid can face a similar challenge when massive new users arrive. What makes AI especially interesting is that many people use it without realizing they're contributing to this growing demand. When someone generates an AI image, uses an AI assistant, creates AI videos, or relies on AI-powered search tools, computers somewhere are doing the work. And those computers need electricity, lots of electricity. But there is another piece of the story that often surprises people. Electricity isn't the only thing these facilities need. They also generate heat, a tremendous amount of heat. If you've ever felt your laptop getting warm after heavy use, you've experienced a tiny version of the same problem. Now, imagine tens of thousands of powerful computer chips working at once. The heat becomes enormous. Data centers need cooling systems to keep equipment from overheating. That means fans, pumps, cooling equipment. And in some locations, large amounts of water. So the facility is not just consuming power for computing, it's also consuming power to stay cool enough to keep computing. This creates a cycle. More AI demand means more servers. More servers create more heat. More heat requires more cooling. More cooling requires more energy. And the total electricity demand keeps climbing. Of course, this doesn't mean AI is the only reason your bill may be higher. If you've experienced rising electricity costs, there are many possible reasons. Natural gas prices can affect power generation costs. Heat waves can increase demand as millions of air conditioners run simultaneously. Aging infrastructure may require upgrades. Population growth can increase electricity usage. Extreme weather can damage equipment and increase costs. AI is one piece of a much larger puzzle, but it's a piece that many people never considered before, and it's becoming harder to ignore. The reason is simple. For decades, electricity demand in many places grew slowly and predictably. Now, utilities are seeing a new source of growth that is both large and fast. Some energy planners are talking about data centers the same way previous generations talked about factories, steel mills, or industrial plants. They have become major consumers of electricity. What's fascinating is that this is one of those moments where the digital world suddenly becomes physical again. We often think of technology as weightless. A message travels instantly. A video streams in seconds. An AI answer appears almost magically. But behind that convenience are real buildings, real power lines, real cooling systems, real electrical infrastructure. The internet may feel invisible, but the machines powering it are very real, and they need energy every second they're running. This creates an interesting question for the future. As AI becomes more common, where will all that electricity come from? Some companies are investing in solar energy. Others are exploring nuclear power. Utilities are expanding infrastructure. Engineers are designing more efficient computer chips. Researchers are finding ways to reduce energy consumption. The race isn't just about building smarter AI, it's also about powering it. Because every breakthrough in artificial intelligence eventually runs into the same basic requirement: electricity. In a way, AI is reminding us of something we rarely think about. Almost every modern convenience depends on energy. Your phone, your laptop, your television, your internet connection, your electric vehicle, and now, increasingly, your AI tools. The digital future still runs on physical power. So the next time you open your electric bill and wonder why the number seems higher than expected, remember that the answer may be bigger than your thermostat settings or the lights in your living room. Part of the story could involve enormous data centers, packed with powerful computers, working non-stop to power the digital services millions of us use every day, including AI. It's a surprising connection. A question typed into a chatbot. A giant warehouse full of servers. And potentially, a little more pressure on the electrical grid that powers your home. And that's one of those everyday connections most people never see until someone points it out. If you enjoy discovering the hidden systems behind ordinary things, that's exactly what we do here. So, if this made you look at your electric bill a little differently, then stick around for the next video by subscribing, liking, and sharing. There is a lot more coming up.